Okay, so we are live. So our
And
today's
now that,
yeah yeah.
share your screen. Share your screen.
Okay guys, so our today's GFG question is transform to prime, where we have been given a array of integers and we need to find a minimum value which need to be added into that sum of the array so that our overall sum becomes an prime number. So let me explain it to you guys. For example, we have been given an array 2, 4, 6 and 6, 8 and 12. If we calculate its sum, it comes out to be as 32. And if we check about it, is it prime or not, it's not a prime number as it is divisible by 2. And so if we increment it by 1, it will become 33, which is again not a prime number. So we increment it again by 1, so it becomes 34, which is also not a prime number. And we increment it by 1 again, which becomes 35, which is also not a prime number. And we again increment it by 1, which makes it 36, which is also not a prime number. So at end we increment this number by 1, so our number becomes 37, which is a prime number. So here we come to the solution that we need to add 5 to our this array so that our total sums become 37, which is a prime number. Okay, so let's write this code. First of all, we can make a simple function to calculate to find if a number is a prime or not. As we know that number less than 2, which are 0 and 1, are not a prime number, so we'll return false for that. And here first of all we'll calculate the sum of our array. And here we'll initialize a count variable to check how many number needs to be added to our array so that it becomes a prime number. And after that we can return our count variable. So let's check the test cases. Okay, there's some error in here. Okay.
After sum is equals to 0 in min number, the epsilon should come.
I was not declared in the scope. Okay.
Int min number. In that function, the first value int sum equals to 0
Mm-hmm.
before for loop.
Yeah.
The sign is you have put comma. It should not be comma. In min number
Oh
second
yeah.
function.
Oh yeah, got it. So it passed our sample test cases. Let's try submitting it. So yeah, it got submitted.
Okay.
Okay, so now to you, someone.
So guys, the question that we have been asked today in today's GFG POTD is that there is a binary string that is given to us, and we have to do a pre-ordered traversal of this binary tree. But the thing that we have to keep in mind while doing this traversal is that after every going down the level, we have to put these parentheses around these variables. And after doing this whole subjugation, after doing this whole notations, we simply have to result our parentheses. So let me just elaborate with you like how this thing is going to happen. First of all, this is our let me say this is a tree or that is given to us, okay, and include only three elements are available. So the way that we have to process this tree in a general pre-order traversal, it should be 1, 2, 3. Why so? Because first of all, we are going to take the value of the root, then we will take the value of the left side, then we will take the value of the right side. So it would resultantly will be 1 to 3 as our answer. Now the modification that we have to do in this problem is that while doing this traversal, I also have to add these parentheses in our code. Now what does that mean? Let's say I am first of all going to be at my first node. So I am simply going to write it as 1. Then once I started moving toward my left and I find a value in my left, first of all I have to establish a parenthesis, then and only then I'm going to read its value. After I read its value, I'm going to check that either left is available of it. It is not available, it is empty. So I'm simply going to return. Then I'm going to check either right is available of it. As it is not, so I'm simply going to return. So after I reach 2, the next thing that I have to do is I have to go back to my 1. So once I go back to my 1, I have to add an ending parenthesis for this open parenthesis. So as a result, I'm going to add an ending parenthesis to it. Then again the same procedure. First of all, I'm going to go toward my right. So as I see the value, I'm going to insert first of all what, an open parenthesis, and then I will write the value. Then the same operation. First of all, I'm going to check either left is available. As it is not available, so simply I am going to return. Then I'm going to check either right is available. So as it is not, simply going to return. So after I return this, next thing is what, from 3 I'm going to go toward my parent. And once I am going to begin to go toward my parent, I have to add an ending parenthesis to this code. So ultimately the result should look like this. So that is what they are asking us to do. Now, as we are going to solve this problem, there are three problems that we are facing while solving the problem. The first one is that the given array or the given string is just like this. The given binary tree is in the form of this, and every node had some element available to it. First one will be this kind of tree. The second tree will be, it would look like something like this. It would have 2 as its child, then it would has 3 as its child, then after that it would only have 4, will only 2 will only have 4 as its child, and there would be no right child. That would be the second condition that we are going to face while solving this problem. And the third condition that we are going to face is that this is our parent node, then we have drawn our second child, then we have drawn our 3, then now for the 2 its right would be empty, but its left will have like left would be empty but right would have some value. Okay, so these are the three conditions that overall we are going to face. Now as I already told you, if the code is something like this, the answer would be what? First of all, we are going to put 1, then will be an open bracket, so it will be 2, then it will be closing bracket, open bracket, 3, and we will be done here. Okay, we don't have to do anything about it. So that would be our answer. Now comes the question regarding this code. So if you understand it, how we are actually going to traverse this code. First of all, we are going to go toward our parent. So we are simply going to include one here. Then I'm going to check if left is available. So as I can see, left has a value. So first of all, I'm going to add an open parenthesis, and then I'm going to pick the value of 2. Then after this, in pre-order traversal, what is the order? First of all, we are going to take the parent, then we are going to pick the left, and then we are going to pick the right. But if the child node had also had its child, then we are first of all going to traverse through our child. Okay, so that is what pre-order traversal says. Like if we have a tree 1, 2, 3, 4, 5, 6, 7, and they are connected something like this, then according to the pre-order traversal, what we are going to do, first of all, I'm going to go at this node 1. Then I will move toward the left. So I'm going to reach it 2. Then I'm going to check that if 2's has any left or right available. So as I can see, in this case, left is available. So I'm first of all going to traverse to my left. Then I'm going to check if there is any other element available. As there is no, so I'm now going to go back. Then I'm going to come back for fifth. Okay, and I can see that there are nothing else available. Then I'm going to go back, and only then I'm going to traverse through my right node. So in this pre-order traversal, first of all, we are going to pick the parent, then we are going to traverse through the left child, then and only then, after we have traversed the left child, then and only then we are going to come back and do the traversal on our right child. So with that said, first of all, we were at parent, so we pick 1. Then we reach it 2, we pick 2. Now before I go to 3, first I have to traverse through my left overall. So as 4 is available here, what I'm going to do, what? First of all, I'm going to add an open parenthesis, then I'm going to read the value of 4. Then I'm going to go down as there is nothing available. So simply I'm going to return. Then I'm going to move toward its right. Check if any element is available at its right. As it is not, so simply return. Then after I return from here, then and only then I'm going to add an close parenthesis. Okay, then simply as 2 doesn't have any kind of right, so we are simply going to return. And then after I return from 2 to 1, only then I am going to add an close parenthesis for my 2 here. Okay, then once I'm going to reach 1, then the next thing is what? Traverse through the right. So as there is an event available, first of all going to add an open parenthesis, then I'm going to read the value, then I'm going to check that if left is available. No, there is no one available at right. Right is available. No, there is no one available at right. So simply going to go what? Return. And once I press the option of return, simply I'm going to add a closing bracket. So now this is our traversal that we are going to get with the parenthesis as per the law of having a child of a child. Okay, now the main issue that we are going to face is in this kind of traversal. Why so? Because in this traversal there is no left available, only right is available. Okay, and if you see carefully the question, in our this subtree, in our this binary tree, there is no left available for 2, only right. There is no right available for 2, only left is available. Okay, so as a result of it, that is why we are getting answer like this. Now understand it carefully, look at it carefully. In this binary tree, for node 2, there is no left available, only right is available. And if you observe it carefully in terms of answer, there is an empty parenthesis that have been taken in this question. So in this question, they have taken an empty parenthesis, and if you observe it carefully, here there is no empty parenthesis. Here are 1, 2, 4, and 3. But in this case, 1, 2, and then an empty parenthesis, then 4, and then 3. So this is a condition that we have to look out while solving this problem. So let's just understand that how we are actually going to deal cases like this. So similar fashion, first of all, we are going to go to our parent node. So we are going to include parent. Then we are going to check if left is available. Yes, as I can see that left is available, 2 is available there. Then the first of all, the thing that I'm going to do is add an open parenthesis and include 2. Okay, after I reach 2, then what I'm going to do? First of all, I'm going to check that if anything available at its left. So as I can say, there is nothing, it is null, nothing available at its left. Now, here the tricky part in this question is I first, before going or before returning from this call, I also have to check if there is any right available in this question. So while checking the left for 2, I am also going to check if right is available. This is a very vital question, like very vital part of this question. Understand it carefully. While checking the left of 2, I also have to check if right is available. And if right is available, then I'm going to go toward my null node. I'm going to go toward my null node, guys. So as I'm going to return back, I'm going to add close parenthesis. So as I'm going to return back, I'm going to add an close parenthesis. Then and only then I'm going to go toward my right, add an open parenthesis, read the value of right, which will be 4, and then I'm going to check if for 4 left is available. As you can see, there is nothing available. Along with that, what do I have to do? I have to check the right. So as you can see, in this case, right is also not available. So simply return an empty string. We don't want to do anything regarding it. And for 4, when I'm going to return to 2, I'm going to add a close parenthesis. When I'm going to from 2, when I'm going to return to 1, I'm going to add a close parenthesis for this one too. Then I'm going to traverse to my right. I'm going to add an open parenthesis, read 3. Then I'm going to check if left is available, as it is not. If right is available, as it is not. So simply going to return the 3. So here it will be a close parenthesis. So now understand it carefully that what do I have to do in order to solve this problem. The first case is that if the given binary tree doesn't have any kind of single child available in its child. So as you can see, 3 doesn't have any kind of child, 2 doesn't have any kind of child, and 3 also doesn't have any kind of child. So first case will be this. The second case will be that if the child contains a binary tree, if it contains something like this, then the thing that we have to do is check. What do we have to check? If left is available, let's say in this case, if you understand it carefully, you are going to find out that we read 1, we read 2, and then when we are going to reach for the fourth part, we just have to check that if left is available. Okay, for 2, left is available. The tricky part comes for our third part, in which this will be our tree. In this, only right is available, left is not available. So the tricky part comes for our third part, in which if left is not available but right is available, we have to add an empty parenthesis in our answer. If only left is available and right is not available, we don't have to add any empty parenthesis. We don't need to include anything. Same goes for this one. If there are no child present, we don't have to include any kind of empty parenthesis. The only thing that we have to be careful about while doing the traversal is if there is an empty parenthesis, and if there is right available and left is not available, then we have to add an empty parenthesis to our answer. This is the case that we are going to deal with. So as I already told you, in pre-order traversal, first of all we are going to go towards our root, then we read the left value, then after returning from left we are going to read the right value. The answer should be something like this. But in this code we have to add parentheses, so the answer would look something like this. First of all we are going to read 1, then after we reach 2, we are going to first of all add an open parenthesis, then after we are going to return from 2, add a close parenthesis, then we are going to read 3, first of all add an open parenthesis, after we are going to return from 3, add a close parenthesis. This would be the answer. The same goes for this code too. First of all, we are going to read 1. Then after we reach 2, we will add an open parenthesis, read 2. Then after we reach 4, because it is a child, so we will again add an open parenthesis. Then there is nothing available, no child available of 4, so we are going to simply add the close parenthesis and return. Then after from 2, we are going to check the right, nothing available, so simply return. Once we return from 2, we are going to add close parenthesis for this 2. It is very important. Then from 1, I'm going to reach toward 3, so open parenthesis, add 3. Then from 3, nothing is available, so simply return. Once I return, it will be a close parenthesis. That would be the answer. These two cases are very simple. These two cases are very simple to understand. The complexity comes in this one, in which first of all we are going to read 1. Okay, then I'm going to read 2. So open parenthesis comes 2. Then I'm going to look for the left, as left is empty, but right had something available. Right is not empty, so then here I have to add an empty parenthesis first of all, then return, then go to right as something is available, so add 4. Then I'm going to check for its left and right, nothing available, so simply add the closing parenthesis. Then from 2, when I'm going to return, for this 2, add a close parenthesis here. Then for this 3, when we are going to read this one, open parenthesis and 3. Then nothing available in left and right, so simply return. When you are going to return, close parenthesis. So that would be our answer. Here there are no empty string that we have included, but here we have included an empty parenthesis. That is only the thing that we have to be cautious about. So as I thought, or as I think that I have elaborated this concept carefully, let's just move out to solve the problem. So first of all, what we are going to do, we are going to take an empty string and we are going to simply call our function. Okay, then in our function we are first of all going to add that node value in our string. So what does this means? We are going to call this function, so this is our one, so we are simply going to add this to our answer. Okay, then the next thing is I'm going to check if node ka left is not equals to null. So as you can see, in this case node ka left is not equals to null, it has certain value. So what he's asking me to do is move toward node ka left. So what I'm going to do, I'm going to simply move toward left, read it with an open parenthesis. Okay, then again when I reach 2, in this code if you understand it, there is nothing available. Okay, and that is the condition that we have applied here. We are here checking that if node ka left is not equal to null, here it is null, so this condition is not matching. Then there is an or condition, and here we are checking if node ka right is not equal to null. In this case it is not. Right had certain kind of value, so what we are doing here is we are going pushing the node, we are pushing the left part, and again we are closing it off. And when I'm going to reach toward the left, when I'm going to reach toward this value, null value, here it is going to read that node is null, so simply return. I'm going to simply come back with my parenthesis. So as a result I have included an empty parenthesis in my code. Now if this condition is not true, that is if left is not available or if right is not available, then simply this is the second condition that we have to check, that if right part is available or not. If right part is not if right part is available, then simply include that thing in our answer and simply return it out. So after we pass this function, we are simply going to get our string as our function. Simple logic is applied here. Those were the three concepts that you have to keep in mind while solving this problem, and as you can see it is working perfectly fine. If we just submit it out, it would work perfectly well. As you can see it is. So the simple concept is this: three trees that we have to keep an eye on. First one will be there are no child node. The second one will be the only left child node is available, right is not available. And the third one, that left is null and right is not null. These two are going to be very simple. These two are going to be very simple. This one would be a little bit complex because we have to include this node here, this empty parenthesis in this case, and usually the logic of pre-order traversal will be followed in this case. So with that, today we have solved both GFG and POTD problem. We hope that you'll be able to understand. And with that, over to you, Shivam.
So, so yeah, guys, thanks for joining with us. We will catch you up tomorrow. Okay, guys.